Okay, we are officially live. Okay. So, you guys, whether you know it or not, you've learned an awful lot. I mean, there's a huge amount around quadratic equations and factoring. You know, all these different types of factoring, which you now know how to do, completing the square, using the quadratic formula. Those are huge, huge, huge. And all of those will be useful as you move into graphing quadratic equations. You can make graphing quadratic equations a very complicated thing, or you can make it really quite simple. And so my plan is to sort of help you guys make it quite simple. But first of all, we've got to understand certain things about quadratic equations. First of all, what is the shape of a quadratic equation? Yeah. Right, it's a parabola, right? Or a parabola, right? And parabolas occur in nature all the time. Every time you drive under a bridge, you've basically driven, well, not every time, but a lot of times bridges are parabolas. If you look at the, they'll have a parabolic shape to them. Every time I throw this thing in the air, it creates a perfect parabola, unless wind starts to blow or something. Then suddenly the wind could throw things off, and it could, it could go up like this, and then it could go way over like this because of the wind. But most of the time, it's just going to be a perfect parabola. And so there's certain things to understand about parabolas. Number one, they are symmetrical. And nature, that's, in my opinion, that's one of the really cool, miraculous things about nature. You'll often see in nature, symmetry. Like if you're in a mountain lake and you see a mountain up above the lake and you see the reflection of the mountain down into the lake, right? It's like a perfectly symmetrical. Or how many people have looked at, I'm sure you all did, when you were kids, looked at the snowflakes. Every snowflake is symmetrical. Absolutely beautiful, breathtakingly beautiful and different. Parabolas are the same thing. They are totally symmetrical. So what does that mean? It's actually a very useful thing to understand. If you have a graph, and let's say I have let's say the graph goes like, I don't know, let's say that's the parabola, right? Well, right here at the vertex, this is called the vertex, by the way. It's where it comes to a point and then it turns around and goes back up again, or it comes to a point, turns around and comes back down again, depending on which way. It could either be like this or like this, right? That's called the vertex. Right in the middle of the vertex is a hidden line that goes up and down. It's sort of an imaginary line, and that line is called the Axis of Symmetry. Very important to know. Axis of symmetry. So make sure you write that down in your book, in your notes. That at a vertex with a parabola, you've got an axis of symmetry that goes right through the middle of the vertex. And it goes up and down, vertical. Okay? Once you understand these things, then it becomes really quite simple to graph these. So, and the beauty of the axis of symmetry is, look at this. If, let's say this is from here to here is two whole places, right? Can you see this? So 1, 2, right? That means because of axis of symmetry, it's going to be from the axis of symmetry, it's going to be 2 to the left as well. So this is exactly the same distance from the axis of symmetry as this is. That means if I go up here, this distance from here to here is exactly the same distance as this distance from here to here, which is really, really useful. Right? Does that make sense? The reason it's useful is it means I don't have to find 2 points. I could find 1 point. And I could ask myself, well, how far is this point from the axis of symmetry? And then I could use the axis of symmetry to go and find this other point. like if this was over 3, from the axis of symmetry, if it was over 3, if it was 1, 2, 3, I would just, from the axis of symmetry, I'd go over 1, 2, 3 and put a dot there. So I would have only had to find 1 dot to find 2 dots. Does that make sense? See what I'm saying? Yes? Or am I losing you? You get it? Make sense? All right, so that's really useful. That means you only have to plot. When you're graphing something, you only have to find one side of the parabola, and then you use your axis of symmetry to find the other side, right? Which is really cool, really, really fast. All right, so that's one thing. Now let's just talk about the quadratic equation just for a second. Y is equal to ax squared plus bx plus c. So now we're looking at the anatomy of this, right? We're going to talk about what we know. To find the y-intercept, so this is the first thing, the y-intercept. How do you find the y-intercept? Think about it. Anytime I've taught you how to do this, what do you have to do to find a y-intercept? I think that was Hannah and Sina very excitedly volunteering this information. They went like this, I think. So, no, seriously. If you were graphing something in standard form, 2x plus 3y equals 12, how would you find the y-intercept? X is equal to 0, right? That's the only time you can cross the y-axis is when x is 0. Same is true with here. So if I made x equal to 0, right, what would the y-intercept be? C, right? That's now 0. That's 0. So y is really c. So c is always your y-intercept. So your y-intercept is always c. That's like huge. That's so easy. You already know a point. The minute you see a quadratic equation on the board, you immediately know one of the points. The c is a point on the y-axis, right? So if I was doing a real problem, okay, so, how do I do this so it doesn't look like a mess? Well, we'll do that in a minute. We'll do a real problem in a minute. But so we've got y, so the y-intercept is always the c. All right, what else do I need to tell you? The x-intercept. The x-intercept. How do you find the x-intercept? How do you find the x-intercept? With a quadratic equation.
Make y equal to 0.
You make y equal to 0. Does that sound familiar? In other words, you're finding the zeros, right? In other words, you can either factor it and find the zeros, right? So to find the y-intercept, you either factor it to find the zeros. And sometimes factoring, instead of factoring, you might use the quadratic equation or quadratic formula. Or you might use completing the square. But you'll always get like, eventually get to x plus 3 times x minus 1 is equal to 0, x plus 3 is equal to 0, or x minus 1 is equal to 0, x is equal to negative 3, or x is equal to positive 1, right? See what I mean? So you're always going to have, you know how to find the x-intercept. It's where the graph crosses the x-axis. That's what we've been working on for the last month, right? You know how to do that. You know how to find where the graph crosses the x-axis. Every time you find the zeros, you just did that. Every time you use the quadratic formula, you did that. Every time you completed the square, you did that. You found those 2 points. All right. So factor it to find the zeros. Right? All right. Now, here's the biggie. You need to know how to find the vertex. All right? To find the vertex. To find the vertex. This is what you have to do. 1, you have to find the axis of symmetry. Whoops. Find the axis of symmetry. for y. First of all, you got to find the axis of symmetry. The second thing you've got to do, the second thing you've got to do, once you find the axis of symmetry, this is the formula for axis of symmetry. X equals negative b over 2a. Does that look familiar? How does it look familiar?
It's
What do you know?
that one formula with the square root.
Right. It just doesn't have the discriminant in it, right? It's the same formula as the quadratic formula, but it doesn't have the plus or minus the square root of b squared minus 4ac. Right? Isn't that awesome? So you already have memorized the quadratic formula, so you already know the formula for axis of symmetry. Just leave out the discriminant, the plus and minus stuff, right? So x is equal to negative b over 2a. Now notice axis of symmetry, if you solve the axis of symmetry, you're going to get an x equals. That means, like if this was x equals 1, 2, 3, the axis of symmetry is 3. So at 3, I do a vertical dashed line. That's my axis of symmetry. Okay? So once you find that, you found where the vertex is horizontally. Right? From 0, 0, you go over to 3, and the vertex is going to be somewhere on that axis of symmetry. The vertex, right? So now you got to figure out where. So you already know your x. Oh, make this a little lower. You know your x. You know your x. X is 3 in this case. You go back to the original problem and you substitute in x 3 for x everywhere and find out what y is equal to, right? So substitute x, value of x, into original problem. Equation, whatever. And solve for y. Then you'll have x comma y, which is your vertex. Does that make sense? Make sense? So now we're going to do it. Now another thing that's interesting is if you knew where your graph crosses the x-axis, your vertex is always halfway between. Right? So let's say this is 1. X is 1 here, 2, 3, 4, 5. This is 5. 1, 2, 3, 4, 5. Sorry, hang on one second. This is not. Anyway, so it's halfway in between, but there's something wrong here. But I'm not going to go there yet. So can I erase this now? We're actually going to do one. Okay, yes? No? Okay. Can I erase the top part, like 1 and 2?
Yes.
And the y equals? Good. All right, so now we're going to really do it. We're going to do the real thing. So we start with a real graph. A new graph, and it's not going to be that hard. So x, we'll see. First I'll graph it. Get our graph. So we got 1, 2, 4, 5, 6. Okay. So let's do something very simple that we know we could actually factor, right? And so we'll do y is equal to x squared plus 3x plus 2. All right? Everybody should be able to factor that really fast in their head if they wanted to. Right? In order to factor it, we would make x to find the zeros, right? To find. Can I erase this part yet?
Yeah.
Okay. Great. All right. So our first thing first thing, we notice our y-intercept is 2. Let's go up here. I'm going to put a dotted 2. That's my y-intercept, right? Makes sense. Y-intercept. So I found my y-intercept. Let's see. I'd like to find where my x crosses, where my parabola crosses the x-axis. How would I do that? That would be finding the zeros, right? Finding the zeros. So, finding the zero meaning making y equal to 0. 0 is equal to x squared plus 3x plus 2. So I would factor this. How would I factor it? 0 is equal to parenthesis, 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 because it has a hidden 1 in front of the x squared. So what would it be? X and x, what? What?
Minus or plus 1 plus 2.
Plus 1 plus 2. So 2 times 1 is 2. 2x plus 1x is 3x. Yes. All right, so my x's are either x plus 1 is 0. So, Teddy, what are you working on? What are you working on? Yeah, just focus on this. So either x plus 1 equals 0, which means x is equal to -1, or x plus 2 equals 0, which means x is equal to -2. All right, so we know -1 and -2 are where it crosses the x-axis, right? That's interesting. Now let's find our vertex. Let's find our axis of symmetry. So let's do that first. So our axis of symmetry. That's the first part of finding our vertex, right? Our axis of symmetry, find the axis of symmetry. I'll just use AOS. So x is equal to -b over 2a. What is my b? 3, right? My a is 1, right? My b is 3, and my c is 2. So it's going to be -3 over 2 times 1, which is what? -1.5? Is that what you get? -3 halves?
Yeah.
Okay, so my axis of symmetry, well, that makes sense. It's halfway between these two x-axes, right? X. So this is my x-axis. My axis of symmetry, right? It's a vertical line, dashed line, that goes up halfway between where it crosses the 2 points where it crosses the x-axis, right? Now there's not always 2 points on the x-axis. If there's only 1 point, that is the vertex. But if there's 2 points, the axis of symmetry is going to go between them. That makes sense. So I know that my x for my vertex is -1.5. So I'm going to go substitute that in to my original equation. So to find my actual y. So y is equal to so it's going to be -1.5 in parentheses squared. Right? See what I'm doing? You guys see what I'm doing? I'm just taking the -1.5 and I'm plugging it into this. So instead of x squared, it's going to be -1.5 squared. I've got to put the negative in the square in the parentheses. And then plus 3 times -1.5 plus 2. All right, so somebody have a calculator? 1.5, I don't know what that is. What's 1.5 times 1.5? 25, 5, 6, 7, 15, 2.25, right? Okay. So 2.25, is that what I just did? So y is equal to positive 2.25. And now this is going to be minus 4.5, right? Plus 2. So, all right, so 2.5, 4.5, 4.5, 0, 2.25. So we've got 2.25, right? So negative 2.25 plus 2 is negative. So we've got negative 2.25 plus 2, which is equal to negative 0.25, right? All right? Did I do that right? Yes. All right. So that means my vertex, this is my y, my vertex is at negative 1.5, negative 1.5 for my x, comma, negative 0.25 for my y. So I didn't plan on giving you, I just made this one up, but I had planned on giving you one that worked out a little better, but that looks about right. And then I'm going to just sort of, now let's look, I've got 2 points here. I've got a point here. All I really need are 3 points. I need the vertex and 2 more points on one side. And look, I've got them. I've got a vertex here, and I've got this point here and this point here. This point is reflected across here. Am I losing you guys?
We couldn't really see while you were doing that.
Oh,
so
I'm sorry.
All
right, sorry. Let me explain. I apologize. Okay, let me explain what I did. So we figured out the axis of symmetry was x is equal to negative 1.5, right? That's my x. So that's why I drew my axis of symmetry at negative 1.5. Now I'm going to substitute that into the original equation, y equals x squared plus 3x plus 2. Okay? Now, when I do that, here I get it. I get y is equal to negative 1.5 squared, which turned out to be 2.25. Right? Actually positive 2.25. Plus 3 times negative 1.5, which is negative 4.5, plus 2. So you can always do this mathematically or use a calculator or whatever, and you would find that you got y is equal to negative 0.25. Okay? So your point, your vertex now is at negative 1.5, because that's what x is, right? And y is negative 0.25. And so if I went to my graph, I go left negative 1.5 and then down 0.25. So it's right in there somewhere. Okay? So that's my vertex. There's a point on the x-axis. All right? And actually this one is symmetrical to it. Here's another point on the x-axis. I mean, not on the x-axis, another point. And that is over 1.5, right? 1.5 from this axis of symmetry. So I'm going to go over 1.5 this way. Half and 1 right here. Put another dot here, right there. And now I have all I need to graph this. All I have to do is start at the vertex and come up like this. Start at the vertex, come up like this. And I have created my graph. I'm going to teach you eventually a much easier way. But this is utilizing everything you already know. Right? So, can I erase it and do one more? I'll do one more that doesn't have decimals in it, so that it won't be quite so complicated. I wasn't thinking when I chose that particular problem. So, I'm assuming I can erase this. So on the homework, there's 4 problems. And okay. All right, so here we go. We're going to do, let's see, let's do y, we're going to say graph y is equal to x squared, let me think, minus 4x plus I don't know. Let's see. Maybe I should make one that we can factor. So x squared minus 4x plus what can I do there? Minus 2 and minus 2. Well, plus 4. We could just do that, right? Minus 2 and minus 2. That would work. Okay. So now we're going to do this one. Here's a bad axis of symmetry. Okay. Boom, boom, boom. It just takes a little getting used to. Once you get used to it. So the first thing we're going to do this time, we're going to find our axis of symmetry. Our axis of symmetry. So x is equal to negative b over 2a. Negative b over 2a. So negative, negative 4. So positive 4, right? So it's positive 4. Negative, negative 4. All over 2 times 1, which is 2, which is equal to 2. So x is equal to 2. Beautiful. That's easy. That's what I should have started with. I didn't. With a problem that was a little easier without the decimals. But anyways, x is equal to 2. That's my axis of symmetry. So I go over on my graph at 2, and I draw a dashed vertical line. X is 2. That's my axis of symmetry. I know the vertex is somewhere on that dashed line. I know it. So now I'm going to find my vertex. Once I found my axis of symmetry, I found my x of my vertex. I have found my vertex is going to be 2 comma something. Right? I'm just going to find the y by substituting the 2 into the original equation. So to find y, I go y is equal to 2 squared, right? Minus 4 times 2 plus 4. So 2 squared is 4. Minus 8 plus 4. Well, what's that? 4 and 4 is 8. Minus 8, it's 0. So y is equal to 0. There is my y. So my vertex is at 2 comma 0. Make sense? It's not that hard. Axis of symmetry gives you a lot of information. Then you suddenly have your vertex. So my vertex is right here. That's intriguing. Look at that. At 2, 0. That's my vertex. If that's my vertex, it's only going to touch the axis, x-axis, in one spot, because it's going to immediately start going up or start going down, right? How do I know if it's going up? What did I teach you? The A must be positive for it to be going up. The A meaning the 1, the hidden 1, it's positive. If it was negative, it would be a very sad, frowny one, right? It would be going down. All of these are going up so far. So great. So now let's think, okay, we need to find another point. What's our y-intercept? 4, right? Our y-intercept is this, right? It's the last number in the equation. So I can immediately go 4, 1, 2, 3, 4, and put a dot. Right. I have now found the middle point and 1 point off to the side. I found the vertex and 1 point off the side. I need to find one more point. So let's factor it. Let's factor it to find my x-intercepts. Let's find my x-intercepts. In other words, find my zeros. So when y is 0, x squared minus 4x plus 4. So 0 is equal to, what would I put here? X.
It's the same thing as 2.
It's minus 2 minus 2, right? Right? Negative 2 times negative 2 is positive 4. Negative 2x plus negative 2x is negative 4x. So they're both going to be, if I said x minus 2 is equal to 0, then x is equal to positive 2. Look at that. That's interesting. So that doesn't really give me any new information, right? That didn't give me any new information. So I actually need something else. It would be really nice to know where it is here, wouldn't it? Right? Wouldn't it be kind of nice to know, like at x is 1, where a dot might be? That might be nice. So I can always do that. I can always choose one. I can say, okay, when x is 1, where's y? And then I could find my other dot. Does that make sense? If x is 1, let's try it. So this didn't really help me because there was only one spot. Let's try it. If when x is 1, let's find out what y is. Y is when it's 1 squared minus 4 times 1 plus 4. Y is equal to 1 minus 4 plus 4. Those cross out, so y is equal to 1. Oh, that's great. So I know that this is a point on the thing. And when x is 1, y is 1. So I could put a dot right there. And I can use my symmetry to go over and put a dot over here. I'm going to use my symmetry and put a dot right here. And I'm going to use symmetry here, go over 2, and I'm going to go over 2 more and put a dot right here. And I'm ready to graph it. And eventually I'm going to show you an even easier way to do all this. But this is good to know. This is all good information. Okay? So that's basically it. So I'm going to pass these out, this homework. That's it for the lecture for now.